Aloha scientists, my name is Dr. Kate Pro and I'm a forensic chemistry professor at Chaminade University of Honolulu. As a forensic chemistry professor, I teach classes in both forensic sciences and in our chemistry courses, and I also get to do research that helps me to find new information to help the field of forensic sciences. Forensic science is the study of science as it applies to the legal system. This basically means that we use forensic science in order to help solve mysteries. In forensic chemistry, we use the field of chemistry to better understand how a crime was committed. If you are interested in becoming a forensic scientist, one thing that you'll need to do is complete a Bachelor of Science degree. Typically, people complete that in fields like biology, chemistry, or forensic science like we have here at Chaminade University of Honolulu. After that, you can go on to graduate school and do more studying, or you can also go out and start working in the field. Today, we are going to use forensic science to investigate inks. Ink could be found at a crime scene on things like printed documents, but also on written notes. Today, we are going to see if we can use forensic chemistry to figure out which pen could have been used to write a note. The ink in a pen is made up of several different chemicals. Each of these chemicals has a slightly different color, and when we write with the pen, or the marker, we actually see the combination of all those colors together. So each of these black markers is actually made up of more than one color. In this video, we are going to show you how to separate the different chemicals that are present in black ink using a technique known as chromatography. This is a piece of chromatography paper, and its purpose is to separate chemicals from one another. Along the bottom, we've taken a pencil and marked a line, and we've left 3 spaces where we're going to dot our samples. In this case, our samples are our 3 markers, so we're just going to put a spot of each marker in each of those spaces. Now we have all of our samples spotted along the bottom of our piece of chromatography paper. We're going to use a piece of chopstick and a binder clip. We're going to clip over top of the chopstick and we'll place our piece of paper here. Our chromatography paper sits inside of the beaker without touching the bottom, but being quite close to it. Now we're going to pour a small amount of water into the bottom of the beaker. We only want it to fill the beaker so that it will be below the level of the spots we've made on the paper. The paper is going to absorb some of the water when we place it into the beaker. The water will then start to move up the paper by capillary action. This is really similar to if you took a napkin and dipped it into a cup of water. The water would start to absorb into the napkin and move up the length of it. When the water reaches the marker that we've spotted, the marker ink dissolves in it. This is like when you take powdered juice, like Kool-Aid or Country Time lemonade, and you dissolve that powder into water. The chemical mixed with the water, and we call that dissolving. As the water continues up the paper, the mixture of chemicals in the ink will move differently with the water. Some chemicals like the water a lot more than others, so they move at different speeds. For example, if a chemical likes to be with the water a lot, or we say has a high affinity for the water, it will move further up the paper. If the chemical likes the water less, or has a lower affinity for the water, it will not move as far up the paper and stay near the bottom. So in this example, we can see that the yellow-orange color at the very bottom of the piece of paper actually doesn't really like to move with the water very much and sticks around near the bottom of the chromatography paper. However, the blues at the top of the paper like to move with the water quite a bit, and so they move upwards towards the top of the piece of paper. In this way, we're actually separating the different chemicals that are present. Look at the finished product that we have here. Remember that these 3 black markers all looked nearly identical when we wrote with them at the beginning of the experiment. Now we can see that they actually each have a different chemical profile. In a laboratory, we can use the chemical profile that's found in each of these inks after separating them out to figure out which pen, printer ink, marker, or other type of ink would have made a mark on a piece of paper. If you want to try this at home, you just need water-soluble markers that you'll use to spot onto a piece of paper towel. We've cut our paper towel to fit inside of our beaker, but you could use any type of drinking glass or a glass jar. We can see here that the results are not exactly the same. Paper towel has a looser weave between the fibers, and so that means that things look a little bit more blurry over here. The chromatography paper is a special paper that's designed to be able to separate different chemicals from one another. So we have a more consistent structure on the paper across, which gives us a little bit more definition between each of the spots. If you want to use what you've learned to solve an actual mystery, you can come up with a scenario with your friends or family members at home. Have one person choose a marker that nobody else knows the identity of, and have them write a spot on your paper towel. Then take all 3 of the markers and write them alongside that unknown mystery spot. You should be able to match the mystery ink after you run the chromatography to a known correct pen. Hope you enjoyed using science to learn about how forensic chemistry can be used in an investigation. In the professional world, scientists use chromatography in a slightly different way. They use large instruments like gas chromatography or liquid chromatography that allow them to find chemical profiles of substances faster and more effectively than the paper chromatography that we used here today. Crime laboratory scientists, for example at a police department or in the FBI, would use similar techniques to investigate evidence in a case involving ink. Museums also use similar techniques to look at different pieces of art and to see the composition of ink within those. Sometimes they might be trying to figure out if a piece of artwork is real or maybe what era it came from. Next time you use your markers to make art, you can think about chromatography.